Class. Today we are going to discuss about the topic concepts of motion in the lesson kinematics. So what are the terms that are related to the motion? We are going to see it now. First term that is very common with the motion is distance. So when an object moves, it has to cover some distance. It will have some initial position and it will have some final position. The total distance, the total length of the path traveled by the object for a particular interval of time is called the distance. And the distance is only the scalar quantity. So the direction is not considered here, only the magnitude value you just add up. So see that in the picture given below, a person starts from the zero position and he walks in one particular direction till 6 meter and he returns back in the opposite direction. From 6 he starts moving 1, 2, 3, 4 and ends up at the 10th meter. 6 meter. After 6 he walks 1 more meter, he walks 1 more meter, he walks 1 more meter. As such, the total distance covered is 10 meter. Here the direction of the person is not at all considered. Whatever the direction it may be, you just add up the total distance he has covered up. So it is a scalar quantity. The next term is displacement. So displacement is again the distance or the path covered by the object, but here it is a vector quantity. As it is a vector quantity, you have to consider both the direction and the magnitude. So you can see that here in the diagram which is given in the left hand side, a person starts again from the 0 meter, he walks in one particular direction till 6 meter and he turns back and returns back in the opposite direction. So as it is a vector quantity, I have to consider the direction here. So the person starts from this position 0 meter and walks over till 6 meter in one particular direction. So let it be 6 meter, and from this point he again starts to move back in the opposite direction. So he covers up 4 meters in the opposite direction. So when it is opposite direction, when we consider the direction, if it is in opposite way, you have to indicate it in the signs. So if one of the direction is positive, the opposite direction should be minus 4 meter. So when you add up this one, it becomes 6 minus 4, which is equal to 2 meter now. So when you consider the direction, the distance covered or the displacement covered by the person becomes now only 2 meters. This can simply be given as the initial position. Yeah, you are taking the initial position and this is my final position as he walks over through the 6 meter and turns back and come back for 4 meters and he is standing here now. So this is my starting position, is my initial position, let it be A, and this be my final position B. So the displacement is this much distance and this much distance. I am from the whole distance I am going to minus of this entire distance as it is in the opposite direction. So only the displacement made by the person is from A to B simply, which can be written as the initial position minus final position. So the displacement is the final position minus initial position. So displacement, let this point be the initial position A, as I said, and he walks away in one particular direction and returns back, and this is my final position B. So the displacement is final position minus my initial position. Which is simply, here the final position is B. So it is B minus A. The point of A, the initial position value is simply 0. So it is 0 and my final position is he's standing at the point 2 meters. So the final position, the position values alone you're going to take, so it is 2 meter. So when you minus it, when you subtract it, it is 2 meters. So the displacement made by the person is simply from the starting point to this point, which is 2 meter, which is simply called the shortest possible distance. So which is what is given here in the case of second diagram also. So the total displacement for this case, see, it is for this point, the initial position is 0 meter, and as the man walks here, he's taking the direction of right hand side, and he's walking till the 6 meter. So the final position is 6 meter. So when the total displacement becomes 6 minus 0, simply 6 meter, you have to indicate the direction as it is a displacement, is a vector quantity. So it is 6 meter right. A vector should have the magnitude and the direction. So this is all about the displacement. Displacement and the distance are the related terms. Here displacement is a vector quantity, the distance is a scalar quantity, is the only difference that makes it. And you have the displacement to be the shortest possible distance that an object can cover. So as I said, displacement is nothing but the difference between the final position and the initial position of the object, and everything should be taken with respect to some time, or else it can also be defined as the shortest possible distance between the object. As it is a vector quantity, you have to mention the direction. The direction will always pointing from the initial position to the final position. So this is all about the term displacement. And you have one more picture here depicting the example for the distance and displacement for your better understanding. A person starts from the starting point. He is moving in a particular direction, turning again back, and he is coming back in the, he makes some irregular shape. The total path of this irregular shape gives the distance. It is simply without consideration of the direction. The whole path length is the distance. And displacement is nothing but the final position. You have to consider only the final position and the starting position, and this will take, this overall distance will take the huge path. Whereas the position from the shortest possible way from the starting point to ending point is this, which gives you the displacement. And in this particular direction, you have to mention the direction, which is from the starting point to the end point. This is all about your displacement. And you can better understand with this example given here. See, a person starts from this point, he is moving towards this direction, which is 10 kilometer. He is moving down in the towards the south direction, again 10 meter, and again from left to right it is one more 10 meter. Again from top to bottom it is one more 10 meter. From right to left he makes 115 meter. And from bottom to top he is making again 10 meter, and again from right to left 5 meter. So plus 5. Without considering the direction, I have simply added up all the distance values on the whole, which gives the scalar quantity without direction, which is simply the distance. When you add up all these values, it is giving the distance value to be 70 kilometer. If it is displacement, you know that you have to consider the direction. So for one particular direction you have to give the positive symbol, and in the opposite direction you have to go for the minus. So it is, for this case, for the first value let me take it as plus 10, and from top to bottom again plus 10, and again from left to right plus 10, from top to bottom again plus 10. Now he is moving in the backward direction, that is from right to left, so it is minus, and the magnitude it covered is 15, so minus 15, and from bottom to top it is again opposite direction, so it is minus 10, and in the opposite direction for 5 meters, so it is minus 5. So now you have considered the direction here with the magnitude value, which is called the displacement. So when you add up all this, you will get the displacement value to be just 14 kilometer, which is simply the shortest possible distance from this initial point to the final point. So as displacement is a vector quantity, you can represent it in the vector format. And let me take the initial position with the position vector representation. The position vector is always represented by the symbol r vector. R vector is my position vector, and the position for this particular point, for one particular point, as I have already told you, it is with respect to the coordinates. You have to write it as x coordinate, y coordinate, and z coordinate. For the vector, you have to represent in the component form of the vector. So it is x1 i cap plus y1 j cap plus z1 k cap for the initial point. For the final point, let it be q, and it is x2, y2, z2. So the second position, that is the final position, can be given by r2 vector, which is x2 i cap, y2 j cap plus z2 k cap. So now the displacement made by the object is simply from the final position to, from the initial position to final position, and for displacement you have to write it as final position minus initial position, which is simply r2 minus r1. This is called this change in the position. Change in the position is always represented by del r. The object has changed its position from r1 to r2, and r2 minus r1 can be represented as change in position, which is del r. So my change in position del r is nothing but r2 vector minus r1 vector, which is simply the subtraction of two vectors. When you subtract, you have to subtract only the component values here. So x2 minus x1 into I cap plus y2 minus y1 into j cap plus z1 into z2 minus z1 into k cap is the displacement represented in the vector component form. This is on the whole. So when you want to represent only the magnitude, as I've already told you, if you have r vector, then the magnitude is modulus of r vector, which is simply the root of component value square. So x square plus y square plus z square. This one we have discussed and you read about the vectors. So it is representation of the magnitude. So for this case, the x value is x2 minus x1, y value is y2 minus y1, and z value is z2 minus z1. So for magnitude, it is it is modulus of del r, which is simply root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. The next term what you have to understand after understanding the basic terms distance and displacement is that speed. So speed is nothing but that is related to distance. What is speed? How fast you travel is the speed. That is, within some fraction of time, how much distance I have covered. If I cover a larger distance within a short time, then it is called I have gone with the higher speed. So it is the related term to speed is that distance and the time. How much time I take to cover a particular distance is the speed. If I take larger time to cover a particular distance, then my speed is lower. Again, as a term, distance is related to speed. Distance is a scalar quantity, so the speed is also the scalar quantity. Simply by representation, you can give it as speed is equal to distance by time taken. it is, this can be simply given as average speed is equal to total path length by time taken. And you have one more term, as it is distance and displacement. As of distance and displacement, you have some other term related to speed also, which is your velocity. So as the same case with distance and displacement. Distance and displacement are one and same. The only difference is distance is scalar and displacement is vector. Similarly, the speed and velocity are one and same. The only thing you are going to consider is speed is a scalar quantity and velocity is a vector quantity. So there, speed formula is speed is equal to distance by time. You does not consider the direction there. Velocity is equal to displacement by time. Here you have to consider the direction also. If the direction changes also, it means the velocity value is getting changed here. So the velocity can be given as the displacement is nothing but change in position. When there is a change in position in particular direction, you call it as displacement. So it is change in position. As we have seen in the previous case, displacement vector is given by change in position, that is del r, with respect to change in time. This is change in time. So velocity is equal to change in displacement or change in position by change in time. So see that speed is nothing but how fast you are traveling in whatever the direction it may be, without considering the direction. Velocity is that the same speed but only in the given particular direction. You have to consider the direction also is for the velocity. I hope you have understood. These are the very basic terms of the thing that is related to motion. Only with this understanding you can proceed with the next part of a lesson. Thank you.